Hello, everyone. My name is Hugh Emberson. I'm a technical director at Pure Storage. And previously to that, I was the founder and CTO of a company called StorageUse, which was acquired by Pure Storage about 3 months ago. And so we're here to talk about modernizing backup infrastructure. And in particular, we're here to talk about this concept called flash to cloud, which we'll get to pretty much at the end of my segment of the talk. Then after that, we'll have a customer segment from David Wartell. He's the CTO of IDT Corporation, and he's a Pure Storage customer. And previously to that, he was a StorageUse customer. And finally, we'll have a demo from Chad Monteith. He's a technology evangelist for Pure Storage. And at the end, we'll have some questions. So if you can hold your questions to the end, we'd really appreciate it. All right, so this is a 60,000-foot overview of sort of the storage technology landscape from Pure's point of view. And really, it's kind of in 3 dimensions. You know, you've got latency, scale, and cost on the 3 sides of that triangle. And I think at this point, pretty much everyone has agreed that your tier 1 storage, your structured storage, databases, virtual machines, tier 1 applications, they all belong on flash block storage. We're at the point now where your tier 2 storage, you know, file and object, tier 2 applications, they're now starting to migrate to flash infrastructure, things like the Pure Storage FlashBlade. But there's this chunk of data at the bottom, the large data that you want to be very low cost for storage, that is still sort of languishing down there at the bottom. It's too big to be economic to store on flash right now. And it's presumed to be low value, but in fact, it often isn't. It's your backups, it's archives, it's content storage, it's that kind of thing. It's the really big stuff that is currently sort of languishing on disk and tape. And we're here to talk about what to do with that third part, that grey part at the bottom of the triangle. And so this is kind of, you know, where we've been, where we're going kind of slide. On the left-hand side with, you know, yesterday, we have, you know, 10 years ago, Tier 1 storage was all on, you know, rapidly spinning, very expensive disk. Your Tier 2 storage was on slightly less expensive, slightly slower disk. And finally, you had your backup and archive storage that was confined to really cheap, slow disk and tape. Now today we've gotten to the point where, you know, Tier 1 is on flash, Tier 2 is moving towards flash, and Tier 3 is still there. It's still languishing on disk, on purpose-built backup appliances, and on tape. And we think in the future, that Tier 3 storage is going to move into the public cloud, where it can get the same or better economics than storing to disk or to tape. And because that data is there in the public cloud and it's live, it will be accessible for more things than just recovery or restoration. So StorageUse is a cloud object storage fabric. What's that mean? It means that it's a software system that scales like the cloud does, that provides the same high availability and redundancy that you get from the cloud. And the core technology that powers storage use is deduplication. So it has that same deduplication style technology that you'll find in purpose-built backup appliances and in most on-premise storage appliances that you find these days. And it has a cloud-native interface. It uses the S3 interface, the same interface that Amazon S3 uses. And you can run it as on-premises, or you can run it in the cloud, or you can run it in both places, giving you a hybrid cloud solution. And you can use it as either a local high-performance deduplicating object storage system, or as a on-cloud deduplicating object storage system as well. And you can use it also for doing things like moving the data between two locations, say your data center and the public cloud. And storage use, just before it was bought, was named a Gartner cool storage vendor, which is something I'm particularly proud of. So how does storage use work? Well, we're going to be talking about mostly the backup use case here. So starting at the left-hand side of this diagram, you have some backup software. It can be anything that has an S3 client or interface. The backup software sends data to the storage use server. Storage use server can deploy on-premises or in the cloud, and it has an S3 interface. So the data comes in over that S3 interface, and we deduplicate that data in line at high speed in memory, and we send the deduplicated data straight through to an object store where we store it and where it is presumed to be very safe. The advantage of doing this, obviously, is that we reduce the data before we store it in the object store, and so we reduce the cost of storing the data. We also, because we're reducing the data, we're reducing the amount of network bandwidth you need in order to move that data into the cloud. And one of the nice things about storage use, one of the things that's very different from other solutions in the space, is that storage use actually passes that data straight through to the object store. And it doesn't cache it in local memory or any local disk attached to the storage use server. It just passes it straight through, and we don't actually we don't acknowledge that we've actually stored a piece of data until we've actually received acknowledgement from the cloud that that data has been stored there. And that means that there is no way that you can actually lose data in the system. If the storage use server is lost or a cluster is lost, your data is always safe in either Amazon S3 or in the other object stores that storage use supports. So a couple of characteristics of storage use. Firstly, it's very fast. Because it's built with a scale-out architecture, like Amazon S3 and like other cloud services, you can scale it up in order to get more throughput. It's stateless, and that's really important. Like, if the hardware that storage use happens to be running on dies for some reason, or if you know you have a fire in your data center, your data is still safe in the object store that the data was stored in Amazon S3, for instance. And you just need to get another cluster, point it at that same bucket in S3, and storage use will be able to recover all your data from there. So you never have a single point of failure in your architecture, where if some hardware component fails or if some set of hardware components are lost, you can lose any data. It's software defined, so the same software that runs on-premise also runs in the cloud. We can move it around and put it wherever you need it to be. And it's enterprise ready. It has features like high availability, replication, encryption, and other features that will meet most of your backup storage requirements. And security is very important. All of the data that goes in and out of storage use is encrypted using TLS. That's the same protocol that you use to access your banking website. So it's secure in flight. But you can also encrypt the data before it leaves storage use and before it's stored in the backend object store using AES 256. And you can store the keys for that encryption in a key management service, something like Amazon KMS, or any sort of hardware security module or key management service that supports the KMAP protocol. So as I mentioned before, storage use has a scale-out architecture. This is what that architecture looks like. It's a shared nothing architecture. Each of the storage use servers, the orange boxes on this diagram, are independent. They're just connected over the network. If you store an object through any one of those servers, it's immediately accessible from any of the other servers. And that means that if you lose one of the servers, if there's a hardware failure or something like that, then you can always pull back your data from any of the other servers in the cluster. You get a single deduplication pool, which scales up as you need it. So you don't get into the scenario where you have silos of storage, where you have to move your data from one silo to another silo to another silo as your needs grow. If you need more throughput, you just add more servers to the storage use cluster. And it's highly available. As I said, any one of those nodes can be lost, and the cluster will just keep on going until you replace it. So what are use cases for storage use? Well, talking about backup, we kind of divide them into two categories. On the left, you have the on-premise backups, and on the right, on cloud. So just drilling down on the left, you have your data stores. You've got, your SANs, your NASs. Hopefully some of those are pure storage NASs, SANs. And then you have some backup application that you use to back those up. We don't change the backup application. You just use whichever backup application that you happen to have. Then what we do change is the backup target. That's the thing that the backup data is stored in. And you can, for instance, on the far left, you can replace your backup target with storage use plus a pure storage flash array and Amazon S3. So the data goes into storage use, it gets stored into that flash blade and Amazon S3 at the same time. You always have two copies of the data. You have a fast one for local recovery in that flash blade, and you have a slow one in S3 for long-term historical storage and for an off-site copy in a really durable store. If you don't need the speed of recovery, you can actually just back up directly into Amazon S3. You don't have to have that flash blade, but you can push your data straight up into S3. And finally, you can do things like replace your tape tier with storage use and S3. On the right-hand side, we've got the on-cloud. So if you're running your applications already in the cloud, you can put storage use there. You can use whatever your favorite backup software is. Again, we're not going to replace that. But you can use storage use and Amazon S3 as a target for that backup software. So how fast is storage use? Well, this is actually a really old slide. We should replace this. But this is a 15-server cluster running in Amazon S3. And it's actually running on quite old EC2 hardware. It's running on Amazon C3 8X instances. And we can actually get the same performance on a cluster of 4 more modern machines now. But we have 15 servers back when we took this. And as you can see, when we did this, we were storing about 8 petabytes of data through storage use. That was deduplicated down to about 237 terabytes of data actually stored in S3. And we were able to ingest that data at about 14 gigabytes per second. We could recover that data at about 7 gigabytes a second. Now, you're probably asking, why is that slower? Deduplicating systems tend to be a bit slower on recovery than they are on ingest. It's because deduplication basically fragments data as it stores it. So we have to do a lot more read operations than we have to do write operations when we're storing the data. And you have a deduplication ratio of 97%, which is about 30 to 1. So it's quite a substantial saving, especially for backup workloads like this. Now, this is how you would use storage use in your data center or in your on-cloud virtual data center. You keep your backup software. If you've got Veritas Net Backup or Veeam or Commvault or Oracle RMAN, you keep those. You replace your backup target, which was a backup appliance or tape, with storage use and S3, or storage use, FlashBlade, and S3. And that gives you faster ingest, faster recovery, and it gives you no single points of failure in your backup system. So, it's highly available. You've got no silos there. If, as the system grows, you can just add more nodes to your storage use cluster. And you can rapidly restore, especially if you're using FlashBlade, you can rapidly restore your data on premises because you're restoring it directly off Flash. So storage use works with most major backup applications. We're a Veritas technology partner, and we work very well with NetBackup. We work with Veeam. Veeam has just recently announced an S3 adapter. We also work with Oracle RMAN and Commvault. And there will be more applications added to this list as we go on. So this is where we get to the title of this presentation. Back in the 1990s, early 2000s, the way you did backup was you had your data on disk, you made a copy of that data and you stored it on some tape, which you took off-site, and then maybe you made another copy of that another copy, and you took that tape and put it somewhere else. So that was disk to tape to tape. In the early 2000s, we moved to having disk to cloud. So we took our data off disk, we stored it on another disk, purpose-built backup appliance, and then we made a copy of that, which we put on tape, and we took off-site. And now, in the late 2010s, we were able to sort of think about doing flash to cloud. So your data's all going to be on Flash now. We can do a first backup to a Flash appliance, a pure storage FlashBlade, and then we can replicate that data up into the public cloud for long-term retention and an off-site copy of your data. And now I'm going to hand over to David Wartell. David is the CTO of IDT Corporation.
All right. Excellent.
Thanks.
Thank you, Hugh. Fantastic presentation. Thanks for joining me here today. My name's David Wartell. I have co-founded brands and companies in the admin, storage, and systems tool space. You may have used like R1Soft and Idera. Currently, I've got a gig as the Chief Technology Officer of this Fortune 1000 company. We do about $1.5 billion of revenue, have millions of customers around the world. The sector that we're in is in communications applications and fintech. And the business that we're in is connecting first and second generation immigrants with their friends and family around the world. And we do that with communications apps and money transfer. At IDT, we have a hybrid infrastructure where we have co-locations around the world, and we also have a significant presence in AWS. Those are connected to our infrastructure with 2 dedicated 10 gig direct connects. And a little bit about flash array. So we got started with the StoreReduce product, and I don't know if you get geeked out about storage and backup, kind of like I do. I'm kind of a geek with it, but I really got excited about the StoreReduce product. We're also using the flash array product to replace an older Oracle Exadata infrastructure. So what we've done is we've brought in basically what's Dell Pizza Box servers connected to flash array, and that's replacing a very expensive Oracle Exadata infrastructure. So it's about 1/5 the cost, and so far we're seeing about 2x performance improvement. And flash array is a big part of that. So about backups at IDT, this enterprise. So we use NetBackup and Oracle RMAN. And about a year ago, a little bit more than, what we had is we had these deduplication appliances. And what happened is this very nervous storage administrator barged into my office, and I was fairly new to my role at IDT, and he said, we have to rebuy all this new deduplication hardware for on-prem backups. And I said, well, why? Are we out of space? Well, no. And I said, well, is it not performing? He said, no, the performance is fine. I said, okay, well, why do we need to buy new hardware? He says, well, the vendor is taking the maintenance costs up multiple of what we were paying because it's 4 years old. And honestly, IDT's the first enterprise that I've had a leadership position at. I've been in commercial software, cloud services. And so I thought this was just insane. Why would anybody do this? We're not going to do that again. And that's when I found StoreReduce. The other challenge that we had at IDT when I got there was they actually had no offsite backups. So they were storing the backups in kind of across the network in different co-locations to these dedupe appliances. But I really wanted options to go more offsite and multi-region. And that was another pain point. So the thing that really made sense with StoreReduce is I like point solutions that solve a particular pain point. And when I looked at other products, we of course did a bake-off, we looked at a lot of different products. They basically required us to rip and replace our entire backup infrastructure. And it was a lot of work, big project, and these are the kind of things you spend a lot of money on, and they just kind of drag on. And StoreReduce is a point solution, so it addressed this pain point of taking our backups off-site to S3. And originally, when the storage admin walked into my office, I said, okay, well, let's look at just sending all the backups to S3. And what we found is that even with the direct connects, we were just sending too much data. It wasn't feasible. And so we'd have to turn up bigger network connections. And I said, okay, we really have to find a way to deduplicate this data. So when we put in StoreReduce, we've got pretty typical kind of environment, VMware farms, Oracle Exadata, NetApp filers. Those are backed up with Veritas NetBackup, Oracle RMAN. And those products, like most storage backup products, they can write to any S3 interface. So they write to the StoreReduce cluster, and that takes the data down to, it's about a 30-to-1 dedupe ratio, depending on the data set. And we pipe that over our direct connect. And how we do that is we have some EC2 instances that act as a Linux NAT proxy. And that allows us to go directly to S3 right through our VPC, so we don't go over the public internet. And so the network bandwidth's free. We had capacity on our direct connects, and we're able to send it right over. And the load on the direct connects originally, there was a lot of people on the team that were worried about all the network bandwidth it would use, but we found that with the dedupe, it really wasn't an issue. One question we get asked is, what did we do with our old dedupe appliances? So we had some fun with them. They're basically junk at this point. And a key thing with that is if you're like, I imagine a lot of, if you have an enterprise, I don't know what business you're in, but if it's an older business like IDT, it's been around for about 20 years, you have some type of on-premise infrastructure, and that may be expanding, it may be shrinking, you're moving workloads to the cloud. And the thing I really like about this is now my backup storage is elastic, because all I have is some commodity hardware running the StoreReduce software, and it's all going to cloud storage. All right. Please welcome Chad, Technology Evangelist for StoreReduce.
Hey. Thank you, sir. Good afternoon, everybody. Chad Monteith. I've Technology Evangelist here for Pure Storage. I've actually spent most of my career in the object storage and the network-attached storage space. I'm really excited here to be a part of Pure and previously with StoreReduce. I joined StoreReduce coming on about a year ago and helped bring the product to market and work on the Pure acquisition. Pure is a great company. We've been having a very clean integration with them, and there's a lot of synergies between the two products and how we do development and engineering, and it's been an exciting time. You've heard about how the product was built from our CTO and founder, Hugh. You've talked about how a customer with Dave at IDT is actually using it, and I'm going to show you a quick couple-minute demo of the product and the interface and show you that this really is something that's real and it's something that's easy for you to take advantage of and utilize. So heading over to our interface here, what I've pulled up here is I'm connected into a Pure lab that we call one of our technology centers. And I'm going to show you here that we've got up on the screen that we've got StoreReduce running. Now, StoreReduce was built with the properties of the cloud. What that means is not only is it stateless and scalable, but all of the nodes can process all of the information just like just completely independent of each other. You can access on one node, you can access on any one of 10 nodes, however many that you need to deploy in order to meet the throughput and the performance requirements, you're able to take advantage of. We did that by ensuring that all of the nodes that we show here have the same configuration. That means you've got one location where you go configure the environment, and that's applied across the board. In this case, we've got a 3-node cluster that we built as part of the lab. And let's hope that VPN is still connected. Looks like it's not, so if you'll let me reconnect it here, we will show you what this looks like. As it connects up, we get a view of the StoreReduce dashboard here. We'll refresh it here. What's important when you're building a system that has those properties of the cloud is that it's very easy to deploy it and to manage it. Our StoreReduce system was often deployed in maybe 20 or 30 minutes. And you can see that from our setting page. When you launch StoreReduce and you build the first StoreReduce instance, you can configure that and have it active and up and running with just a few pieces of information configured. And here you'll see our setting page, and pretty much you just put in a license, define that you're using Amazon storage, and that Amazon storage can be in the public cloud or it can be an on-premise FlashBlade. Assign your endpoint, your bucket name, and your access credentials. That's all it takes to get StoreReduce up and running. We oftentimes had customers or demo environments where they would get these stood up in maybe a matter of 20 or 30 minutes. You can add systems to the cluster just as easy. When you go and deploy the cluster, you want to add additional nodes. There's an identification key. You can add additional nodes. They automatically configure themselves, redistribute the data across them. You can scale up, you can scale down in a very elastic manner. The importance with this particular configuration, what we wanted to show in the demonstration here, is what we also showed last week in our cloud launch. So if you've got a moment, I would suggest that you go take a look at that. We show a lot of these same demos as part of that. In the demo, we built a system where we wanted to highlight that you could write to StoreReduce while simultaneously copying that data to the FlashBlade on-premise and sending it to the Amazon cloud. And that's where our replication technology comes into play. Because as these demos are being done, as we're writing data in, we're writing that deduplicated compressed data to FlashBlade so you can take advantage of that rapid restore, that on-premise, high-speed, high-concurrency restore process, while simultaneously copying that data up to the Amazon cloud. So you not only got the performance benefits of on-premise, but you've got the durability capability and the durability benefits of the public cloud. In that case, we configured it here. Again, very simple. You apply your credentials and where you want the target to actually reside in Amazon. and we can show from this demo, it's US West 2, the bucket, and the credentials. That is all that it takes to set up that replication job and have all of your data visible in Amazon. In this case, we had a few environments that we stood up. NetBackup, Oracle, and Veeam are what we demonstrated here. I'm going to show you the videos that we had from those, as we've got them pretty succinct here. The first one that I have was showing that we had 3 NetBackup servers and we had 3 StoryDew servers, and that we're able to saturate those 10 gig connected networks. So you'll see in this video that we've got an Oracle workload that's actually writing. This was actually the restore demo. Let me grab the right demo. We've got a workload that's being automatically generated within NetBackup. It's actually doing a 91 deduplication rate. I'm sorry, a 90% dedupe rate, which is a 10 to 1. And we were able to saturate all of the links while copying all of that data simultaneously to Amazon. You can see in there those performance numbers at the end that that's what we were successfully doing. What's important to this, and with any backup environment, is that you can back up fast, but the real value, the real benefit is when you can restore fast. So this one is a restore on-premise of 2 Oracle backup, of 2 Oracle servers that we were restoring on-prem into a flash array. This one was actually able to keep up with both of them, pushing about 1.5 GB per second as we were restoring both databases. Again, because StoryDew is inherently highly parallelized, we can take native advantage of flash, we can take native advantage of the cloud. These are not serial processes, these are built because it's deduplicated, because you've got lots of small fragmented pieces of data. The cloud and flash arrays are natively have a core advantage to being able to restore that at a very high rate of speed. What we also want to show here is that, say for some reason your on-premise system was lost and you need to restore natively in the cloud. You can spin StoryDew in your entire backup environment in the cloud and restore that there. Or if for some reason you're not able to restore on-premise, maybe you've got a tiering process in place and you want to bring that back from the cloud, we demonstrate that here. And a big advantage of StoryDew and what it does here is that we were able to saturate those links as we brought that data back from Amazon. So we actually, in our lab, we only have a 1 gigabit link, but we are able to restore this 2 terabyte database very fast by saturating that link and bringing it back. Many deduplication technologies are not able to do that. So with that, let me bring Hugh and David back up. We demonstrated here the StoryDew GUI, the speed of the backup, the speed of the restore, and the speed of the restore from Amazon Cloud as we did that replication. And we'll open it up to Q&A. Don't all ask questions at once. I'm sure there's lots of questions for us here. Yes, sir.
So as a pure array user, now that they've acquired you guys, do we get you a discount, or do we get you for free, or?
You want me to take that one?
Yeah, sure. You're the SE.
All right. The plan for StoryDew is that we will be launching early next year a 3rd product line that you're going to be able to utilize along your pure flash arrays and your flash blades. It is not a technology that's going to be directly included in any of the existing technologies, so it's not going to be a free upgrade by any means. But you will be able to utilize it to take better advantage from a use perspective of your flash blades, and we've got a number of integrations, especially those ones that we talked about at the cloud launch, to tie flash array with things like Cloud Snap, Snap to NFS, and things like this with this technology as well. Okay? Yes, sir?
Is 30 to 1 compression ratio expected? And Veeam also does some dedupe compression, and so does the storage appliance as well, correct? So just trying to understand what to expect from this on top of it.
Yeah, deduplication rates are highly dependent on the data that's being pushed to it. So, you know, your typical best practices around a deduplication engine for data type is going to apply. If you're backing up the same data type, retaining for a substantial amount of time, you're going to get higher deduplication rates. If you're backing up data that itself is already optimized, video, media, images, you're not going to get much of a deduplication rate from that. We do see a wide range based upon those data types. We've seen customers that normalize around 8 to 1 across their enterprise. Some environments have been as high as 30 or 40 or 50 to 1 with some types of data. But again, standard deduplication assumptions and best practices are going to apply there. To your question about Veeam, Commvault, NetBackup, yes, many of those technologies do have the ability to send deduplicated and compressed data. In general, and I'm going to kind of normalize this and talk at a high level across all of them, the difference with StorReduce is that we've implemented and built a variable length deduplication engine followed by a compression portion in our pipeline. So what that's going to allow us to do, especially in backup workloads, is have a better match from a granularity perspective. So typically we're going to see better dedupe rates, or at least matching dedupe rates with some of the best other technologies out there by utilizing that variable length engine. In particular with Veeam, Veeam, the way they implemented it, they're able to deduplicate within jobs, and they use a larger fixed length that you can configure type of block size. The difference with StorReduce is now you're going to take all of those Veeam media servers, environments, jobs, etc., write that data down to us, and then we're going to deduplicate and compress across all of them. So when you look at it from an enterprise-wide perspective, you're going to get some definite advantages there versus looking at it from like a job or a particular individual backup type of perspective. Did I get all your questions? Was there another one in there? All right.
First question is, how do you respond to prospective customers that are concerned about that first error, from the client to wherever the media agent or the storage node is located, in the sense that when you use the backup vendors, you do technology like he was talking about, that's a skinny error. When the client doesn't know about that, then that becomes a fat error. I understand that once it gets the storage use appliance or your technology, it's going to be a skinny arrow downstream. Everything upstream of that, it's a fat arrow because the client doesn't know anything about the procedure. That's the first question. The second was the replication. I think that's a really cool idea about the replication. It can be flash played, and immediately this is background is replicating out to the bucket. Again, coming back to the integration, how does someone think something like Commvault or NetBackup or Veeam know about that second copy so that it's cognizant and catalogs that and can use that for you?
Sure. I'll start with the second part.
I'll take your first question. So if you remember that slide, we have these different co-locations, and we also have some remote offices. So what we've done is put StorReduce locally in those locations, and then just, if they're smaller, take them right over public internet to S3. So I don't know if that answers your question about the size of the pipe.
The data from the client in that remote office to the that you put on-prem in that remote office, that there's no deduplication or compression there.
But between inside the office, yeah, there's not. So it's going right from the client right into StorReduce on-prem, and then it's being duplicated before it goes over the internet, or dedupe.
Yeah, I mean, I think there are a couple of dimensions to this. Yes, if you do deduplication on the client, you will reduce your network bandwidth, but you'll also use some other resource. So nothing comes for free here. And if you are doing deduplication on the client, then you're going to be using a lot of CPU on that client. So, it depends on what you're optimizing for. If you're optimizing for a low bandwidth network, then maybe client-side deduplication is the way to go. If you have a high bandwidth network within your location, your data center or whatever, then there isn't much extra bandwidth to worry about, but you're not actually hitting the CPU on your production systems to do that deduplication. So it's a trade-off. All of these things are trade-offs. And the second question was?
That's a great point, Hugh, about the client-side versus server-side dedupe.
The second question was?
Yeah, the second question you had was, I think in answering that, the important thing to note is what is the interface, what's the access point for StorReduce with a typical backup application. What's key is that you're still utilizing your existing backup application, Commvault, NetBackup, Veeam, Oracle, whatever that is, whatever that interface from those media servers to the clients, to the servers, is going to remain the same. So you're not really touching that front side. Whatever you're doing, you can continue to do. What we're interfacing with is on the back side, on the right side, where the media server goes and connects to, instead of a data domain or a tape or something like that, it's going to connect to StoryDeuce. Now those applications have all built in to themselves a cloud connector of some type, some sort of method to write data to the cloud. And with StoryDeuce, they're going to send that data in as raw of a format as possible. That means you're not going to compress, deduplicate it, encrypt it, things like that. You're going to let StoryDeuce handle all of that. Now, StoryDeuce is presenting that single global namespace. So that means we are taking care of writing the data on-premise and writing the data in the cloud. So your backup application doesn't have to have knowledge or visibility that we're putting all these copies in different locations or that we've got multiple locations where we're storing that data. Instead, they just need to know that I've got this endpoint that is StoryDeuce that's going to place this data based upon how you configure it in that policy wherever it needs to reside. And StoryDeuce now, with that global namespace, as you write into it, if it's not available in one location, we're simply going to go retrieve it to that application and serve it back to the client from another location. So now the application, your backup app, doesn't have to have visibility of, well, I've got replicas in all across the globe, and I need to manage them and decide where to go. No, you let StoryDeuce handle that, and we'll go proxy and broker those requests to you, and just ensure that wherever the data resides, we can get it back to the client application when it requests it.
Yes, I mean, depending on the backup application, there are different ways to do that. To basically, update the catalog so that it knows about that second application.
You're saying that you just know one copy and it's in the cloud. You're not tracking.
We're talking highly optimized duplicate copies of the data. But, yeah. Storages. No. They're just one copy. Yes. We just worry about the one copy right now. But there are ways of doing catalog imports, for instance, so that you can make a second master server aware of data that's been backed up through storages so that it can access it from a second location.
And utilizing those processes allow you, if you're utilizing AWS and you've got that other copy in S3, you are able to bring up your master server, whether it's a secondary one or part of the original domain, and have access to that data native within the cloud as well. So you can do a fully cloud resident restore of the data. It's S3.
Yes, sir.
Yeah. So StoryDeuce is a layer with S3 out the front end and S3 out the back end. If you're looking at non-flash array, non-S3 type of storage, then we'll have to have a separate conversation about that as to whether that's appropriate and something we're going to support.
Any other questions? We'll be making more announcements about that early in the new year, and in particular how the storage use software will be deployed as a pure product. But if you're interested in perhaps doing a beta with us, we can have a discussion later.
Yeah, so for example, in the case of my deployment, it's some Dell commodity servers with a 1 terabyte SSD drive. That's all there is to it. Very inexpensive, not a lot going on.
Yeah.
Are you guys at your booth? Is that where you'll be hanging out?
Chad will be
I'm there.
hanging out there, yes, and Vanessa here as well.
Can you make use of the secondary copy of the data?
Yeah. Because you're still utilizing to write the data to us, your current backup application, you're going to need to utilize the process and the features and functions of that backup application to bring the data back and make it presentable. When it's written to storage use, it's just in a raw format that application is written to us. We're not necessarily going to take that and expose it from a read-write perspective outside of that application. Figured that was me. Got quiet for a minute. So you're going to have to utilize the features and functions and the process of your current backup application in order to restore that and make it visible. So if they have that capability, StorageUse is going to continue to enable that capability.
Yeah, so we don't replace the backup software, we just replace the target, the thing that backup software writes to.
Your current processes, yes.
Yes.
Mm-hmm. Did you have a question again? Okay. Any other questions?
Yes.
Well, if any come up, you know where to find us. We'll be at the Pure booth. Thank you, everybody.
Thank you.